In this video, I want to demonstrate how to deploy a Flask application with PostgreSQL database to an AWS Linux 2 AMI EC2 instance. And I think to get us started, I will walk through the architecture of the application that I'll be deploying. So what I'm showing here is a request response path diagram. So on the left we have a user and a laptop making a GET request to any application in this architecture. So the key to this diagram is it shows all the touch points and the full technology stack that such a request has to cut through in order to get the content that's ultimately returned in a response and displayed to a user when they make a request on a system like this. So the outer layer is our Linux operating system server. So that's the host server that's going to be sitting there out there in our virtual private server listening to ideally like port 80 or port 443, and then handing requests off to a web server, which in this example is going to be nginx. So nginx will take such a request, and the way in which I'll configure it is for any static content that falls within the static URL path, then nginx is actually just going to serve up a like a static file such as JavaScript, CSS, maybe images, could be media, I guess, and then return that type of a response immediately. All other such requests in this architecture get reverse proxied to yet another type of server called uWSGI. So uWSGI is an application container server for a couple different common Python web frameworks. In this example, I'm going to be using Flask. So that request gets reverse proxied to uWSGI, which then invokes the Flask application framework. And then the code that we write in Python and in Flask deals with that request based off of what's being requested and maybe some body parameters and stuff if it's a post. And if necessary, it'll reach down into a database layer, which in this example again is just a PostgreSQL database installed on the exact same Linux host server. And then, so our Flask application will package that up into an appropriate response and pass it up back through the layers and then across the network to the user. So that's the general architecture that I'll be discussing and demonstrating how to deploy in this video. So I think a quick demonstration of the application is probably in order. So I'll just set up a quick local environment on my laptop here, starting with creating a Python virtual environment. And then I'll activate it. And then I have a set of requirements here in a requirements text file, which are Flask, Flask login, Flask migrate, and SQL Alchemy work together to give us our data access layer. And then python.m for reading in a .m file full of environment variables, the PostgreSQL database driver, and then I use the requests package for getting some metadata from an EC2 instance once we finally install this. And then there's that uWSGI dependency. I won't use that actually for the local demonstration on my laptop, but we'll use it on the server. So let me do a pip install -r and then requirements.txt. Okay. So I'm going to work with a local PostgreSQL database that I have previously installed, and I'll walk through how to install this on our server. I just want to make sure that it's clear what we're installing at first. So if I connect to my local database on my laptop, I can create a database, and we'll call it to-dos because it's a to-do application. I'll quit out of that now. Okay, so I have this Flask app here, and that's this guy right here. So what I want to do is I want to make an environment variable called Flask app and set that equal to Flask to do. And then now I can run my database migration with Flask db upgrade. Uh-oh, gotta update the environment variable first. Okay, so local host, and then to-dos was the name of the database. So PostgreSQL, Postgres. Okay, so that's the anatomy of our connection string URL. So I can now do what I originally was trying to do. Alright, so now my database migrations ran, and I should have a couple of tables in there mapped to the models in the model class, which is just a simple user, and then a to-do table, or to-do model. So, I can do a Flask run now, and I'm going to run this on port 9009, sure. And then I can copy that, and we'll go to Safari, open up a new tab, and I'll pull that up. Alright, so there is our to-do application. Let me sign up real quick. We'll call Adam, and then, no, I don't want to use that password. I'll put in a random password, push submit, and don't worry about that. Okay, so now here's our to-do application. I can put in a to-do like demo installing Flask app, install nginx, micro-WSGI, Flask, PostgreSQL to AWS EC2. And there's our to-do. Delete server, after install, delete server to save money. Okay, so that's 2 to-dos. That's enough for demonstration purposes. So now basically you can just view them, you can mark them as complete, and then now they'll show up in the completed tab. I could then delete or archive, and that one's going to show up in the archive tab now. So I think you get the point. This is the application. The main thing is it handles authentication, it talks to a database, and it's that should be enough for our purposes, just to play around with something to install. Okay. So enough playing around with this stuff locally. Now what I should do is hop into the AWS console and go to my EC2 dashboard, and I'll fire up a new instance. So if I click launch instance, I'm going to select the AMI Linux 2 or Linux 2 AMI from Amazon as the Linux EC2 distro, and should be able to just accept defaults. I don't know if you saw that in the previous one, but I just went with the T2 Micro, so it's cheap. And then for demonstration purposes, that's totally fine. In a real life situation, you're probably going to want a bigger server than that. But I can essentially just accept defaults for most of this stuff, except for security groups. So for the security group, I have a pre-made security group that enables inbound traffic for port 80, 443, and SSH on port 22. So I'll go ahead and use that. If you don't have one, just create a new one and add a couple of rules to match what I just showed. But once again, I'm going to use a previously created one. Now I can do a review and launch. And I'll select a key pair that I know I have. And we'll let that thing spin up. Alright, so this is going to eventually hit a running state, and then we can use this IP address right here. So you just click the row in the table of the new instance, and then you'll have a details section under description, and you should have a public IPv4 address pretty much right away, but you might not be able to get onto it until we're hitting the running state. Okay. Cool. So now I have all of this detailed here in a blog post I wrote recently. On my blog, the coding interface. So I'm going to use that as our cheat sheet for a lot of the install commands. Because it's not really, in my opinion anyway, it's not the best idea in the world to memorize every command for installing something. It's best to automate this type of thing. And I will be talking about a course that I also offer through, and I am selling on the Udemy platform, that talks about how to fully automate Flask installs to AWS. But it's still good to show how it's done manually, because once you figure out that, you can pretty much automate it with just a little bit of work. So anyway, this is what I'm going to use as my cheat sheet, just to be open and honest about what's going on here. So if I now SSH onto this new EC2 instance, back on this tab, alright, we've reached our running state. That means I can get on it. So back to my terminal, and then I use the -I and I point that at my PEM key. Yes, I'll accept. Okay. So first things first is always update a new server to install the latest and greatest patches and other necessary fixes. To do that, I'm gonna run everything as root. So hopefully this is clear enough to do a side-by-side of these two windows. Alright, so sudo su takes me to root, and now I can do a yum update -y to accept that I do in fact want to update the system. Alright, so I'll talk through some of these other packages that are being installed, why the update is running. So the Amazon Linux 2 AMI comes with quite a bit of stuff pre-installed on it, because it is sort of their own version of a Linux distro. Basically, it's just a Red Hat Enterprise Linux or CentOS type of a distribution that they then install some additional packages on it that make working with the AWS platform a little easier. One of which is this Amazon Linux Extras install, which basically just updates its packages using their curated list of available downloadable software. Okay, so that ran. Now I can install nginx. So nginx, again, from our diagram, is just the web server that we'll be using to either serve static content or reverse proxy to the WSGI application server. Git is version control. I'm assuming most of you know what that means. GCC is a compiler that will be needed to install the WSGI dependency. And then build essentials. Gosh, where's B? Okay, there we go. Build essential is also used to build that WSGI dependency, and we'll let those run. And then I'm installing the Python 3 environment that we'll be working with for our Flask application. So let me pre-select that. And then copy over here, push enter. Alright, and then I'll use the Amazon Linux Extras utility now to install Postgres, or I guess not necessarily install it, but it updates the package list with that version of it, of Postgres, so PostgreSQL 11. And then we should see a highlighted line here. There we go. So that basically says, okay, well that's available now on our installable packages list. And then I'll run a yum install PostgreSQL Server. Okay. Next thing that will be good to do is to set up the Postgres database. So Postgres, when you install like we just did, it does a few things. Not just does it install the software packages, but it also installs or creates an admin user. So that admin user is named Postgres. And you use that user to do admin stuff like make new users and create new databases. So that's what I'll be using it for. I'll be using it to create new users, particularly a Flask to-do user, and then the to-dos database. But before I can do any of that, I need to initialize the data directory. So you use the pgctl command, which is just a Postgres utility command, to initialize the database. Alright, so now I can exit out of that and become root again. So who am I? I'm root. Now I can run a systemctl start PostgreSQL, and then we can do a status on that to make sure it started correctly. And it's running. Great. So one last thing to do to keep that in good shape is to enable it. That way it restarts itself when we reboot the server. Okay. So now I want to go back to that Postgres admin user, and I'll create that the user that we're going to use from our Flask application to connect to the database. So another thing that gets installed when we install Postgres is some admin utility programs called, one of which is called create user, which unsurprisingly creates new users. So I'll use the -e flag to echo out the SQL that gets submitted to the database engine, and then pw prompt asks me to give this new user a password. And then I follow it with the name of the user. So Flask to do will be the name of the user, and then it'll ask me for that password, which I will do Flask to do. Sorry, backspace a little bit. Flask to do app user, and then Flask to do app user. And then there's the SQL that gets submitted to the database engine. Alright, next thing is to create the database. So another utility program provided by Postgres is create DB. So we'll do -e to echo again, and then I'll type owner and give it the value of Flask to do. So the user that we just created, that'll be the owner for this database. And then I just need the name of the database, which I think was to-dos. All right, so there's the SQL, create database to-dos, owner is Flask to-do. Fantastic. Next on the list is to clone the application that we just demonstrated here locally. So I have it sitting in GitHub over here underneath my GitHub repo or my GitHub account. So I'll link to this at the bottom of the video. So you'll want to go there to this public repo and click the clone drop down and then select either SSH or HTTPS. I'll do the HTTPS one for this demo, and I want to exit out of this Postgres user and become root again, and I want to make a directory to serve this Flask application out of, which I will do that at var www, which is just a very common directory for serving web applications out of. And then I'll do a git clone, and then I'll clone that to var www. Alright, so nice and cloned. And if I go back to my deployment cheat sheet here, we see that I've cloned to where we want it to, and now I want to cd into that new var www directory, and I'll create a Python virtual environment. Which we'll use to run the Flask application in its own isolated environment. And then I'll activate it. So source vim bin, oops, can't double source it. Source vim bin, activate. And then, so this is the Git repo that we installed or cloned from my GitHub account. And just like what we saw locally here, there is that requirements file. So again, with my activated virtual environment, and we always know it's activated because we've got this updated prompt symbol, I can do pip install -r requirements. Now this will take a little bit longer than what it did when I first did it locally on my laptop, because this step right here, running install for the micro-WSGI dependency. So that uses a lot of custom C and C++ extensions, which require a compilation step, and that's a good thing because that actually makes our web apps run a lot faster with that web server gateway interface protocol. Okay, so that installed nicely. Alright, so next thing to do is to create a .m file here right at the root. So again, the same place as the requirements.txt file is where we want to make an environment variable file. So we'll call it .env. And then I fill that with two environment variables. One is the secret key value, and normally you'll use a much probably longer value for this and less easy to guess than that in a real world context. And then the database URI. And so this actually matches exactly what we did when we created the Flask to-do user. So if we break down the anatomy of this database URI string, it says to use the PostgreSQL driver or communication protocol and connect with the Flask to-do user. This is its password. And then where is it running? Localhost, so this server. and then the name of the database, to-dos. Alright, so now I can save that, and there it is. Okay, so now I want to run the same migrations that I ran locally on this remote EC2 instance. So Flask to do is the name of the application, of the Flask application. And then I can do Flask DB upgrade. And so that now ran on that new database that we just installed. So it's complete with the users and to-do table. Alright, so the next thing we'll do is we'll configure the WSGI container server. So in this repo, I have a config directory with 4 files in it. 2 are for configuring the WSGI container server, and 2 are for configuring nginx. So this first one, flask_todo.ini, is a settings file essentially for the WSGI container server. And what this does is it defines the module that contains the callable Flask object that speaks Web Server Gateway Interface Protocol. And so we see here it is set equal to WSGI and then a colon in app. So what does that mean? So that means that we expect it to look in this file right here, wsgi.py, so that module, and then inside of it is an app variable. So in this Flask to do application, I'm using what's known as an application factory pattern. So inside of Flask to do's package, there's a create app function. So let's take a look at that real quick, just so you know what's going on. So here's our create app function. So what it does is it instantiates a new instance of a Flask object, updates the configs based off of those environment variables, or updates the configuration of that Flask application object with the environment variables, was what I was meaning to say. Then it does some other stuff like registers an error handler, initializes the database and the associated models, as well as the migration extension, and registers some blueprints. And then I have a context preprocessor, so I can stuff in an instance ID for the EC2 instance that I'm currently installed on, and that's just kind of for teaching purposes, I guess. So I use the requests package to make a GET request to a common AWS EC2 metadata REST endpoint that's accessible from any EC2 instance within the Amazon cloud. So I use that to fish out the exact instance ID that we're running the app on, and then I display it in a template. So this isn't really like a video on how to code Flask, it's a video on how to deploy Flask. So I'm not going to go into every piece of code that I have written for this demo application. I just want to cover the stuff that's pertinent for the install, which in my opinion is really just the create app function. Alright, so that kind of covers what the module is, and then master basically has to do with how processes are created and cleaned up. Processes equal to 5 is a parameter that you can tune for performance purposes. So usually you want about the number of processes that you have as cores. This is way too high for our example here with that tiny T2 micro. but for demo purposes, I'll just leave it at 5. Just know that you usually want to have about the number of processes as you have cores on your server. And then I set a virtual environment path. I tell it to make a socket in the same directory, and we'll call that socket Flask to do. And then we change the file permission of that socket to an appropriate value, tell it to clean up itself, give it a place to log to, and again, tell it to clean up its processes when it dies. Okay, so that is the settings file. The next thing that's important for configuring and running the micro-WSGI container server is this Flask to do service script, or service file. So this is just a systemd unit or service file that specifies how to run the micro-WSGI service itself. So here I just have a general description, and then I say it should start on reboot after the network group comes up, and then the service should run under the EC2 user and within the nginx group. I give it the working directory that we installed to. I update the environment path to point to the virtual environment that we installed. And then I give it the start command, which is just to call the micro-WSGI binary that was installed and then pass it a path to a config file, so an ini config file that we just went over. And then it should belong to the multi-user runtime target. Alright, so that's the micro-WSGI part of things. So let's copy those, or copy the systemd unit script or unit file into the etc directory that user written systemd unit file should go into. Alright, so back on the server, we see there's that config directory. So let's cd into config, and so there's our Flask to do service file for systemd. So I want to copy that to etc systemd and then system. So that's where you always want to have your user defined or your own custom service files. So Flask service. Copy that there. And then we'll make sure that it made its way over there. Let's see, systemd system, and there it is right there. Awesome. And I'll update the permission for that. So chmod 755 to be consistent with, well, I guess those are directories. No, never mind. I don't need to update that. That'll work just fine the way it is, I'm pretty sure. Alright, so that covers the micro-WSGI side of things. Now is all that really is needed is to create the logging directory, which maybe we could go back to that. Alright, so we want it to log here. So I will copy part of that and I'll make directory there. Now what's on the to-do list? Okay, so I want to change the ownership to that logging directory so that our service can write to that directory, because right now it's owned by root. So I'll change the ownership to EC2 user as well as nginx, which is what is running our service. So again, user and group was just that exactly, EC2 user and nginx. Alright, so now I can start. So systemctl start Flask to do service. and we'll check the status of it. And it failed. Why did it fail? Configuration file entered into a failed state. Well, let's see why. Oh, you know what? I know why. So right now, everything's running as root. Everything is underneath the root user and group. But as I just described, we want to run our service as the EC2 user, which is the default non-root user. So it's generally a bad idea to run everything as root. So we will change ownership recursively to EC2 user nginx var dub and try that again. All right. All right, now we're running. Cool. Sorry about that. I should have thought to do that before. So that's running. Now what remains is to enable it. Again, enabling simply means that it will start automatically on a system reboot. Okay, so that's the micro WSGI part of things. Now let's move on to configuring nginx. So the other two configuration files, and I'm going to close some files so it's less confusing. Okay, so the other two configuration files in this config directory are nginx-conf. So this is just changing the default configuration for nginx itself. And what I want to do is I take this default server block that's normally not commented out and I comment it out. And I do that because I want our Flask app that we're installing to be the default server and not this block here. This block simply just points to some default nginx HTML files that are kind of like a hello world type thing almost. And that's not what we want. We want a custom app, not the silly stuff that nginx provides us. So I comment this part out, and then I basically just copy that into the place where it gets installed. And then this is an important line here. It comes with this line already, so you don't have to worry about including it. But what it says is it's going to look for alternative configuration files in this etc nginx confd directory. And so that is where we're going to put the custom one. So Flask to do conf is the custom nginx config for this Flask app. So what that does is it says to listen on port 80 for IPv4 and IPv6, and that this configuration belongs to the default server. And then the server name is just this underscore variable catch-all thing. Normally you'd probably put in your domain name and then maybe even the IP address for the server. I'm not going to cover that in this video. I do in my course that I link to, but for our case we're just going to use this catch-all variable. And then I have two locations defined, and that's consistent with our diagram that I started off the video with. So anything that comes through to static as URL path should be served out of the static directory that lives at var dub flask to do. So it just so happens that's almost right where we are right now. So in the var dub directory, and here's the flask to do directory. So if I do that on flask to do, then you'll notice there's the static directory, and that just contains I don't even remember what it contains. Okay, yeah, so it contains the Bulma CSS, some custom CSS that I put in, and then a JavaScript script. Alright, so if one of those requests come through, nginx is going to take care of that for us, and we're not going to have to invoke Flask at all. Anything else, then those requests get reverse proxied to the WSGI application server, and it's going to pass through communications through that socket file. Alright, so let me go ahead and show you where nginx's default configs live. So they all live in etc nginx. So here's the default one that we're going to overwrite. So let's just, for good practices, we'll move that or rename it to nginx and we'll call it original. Now we can copy over the one that we just reviewed in the config directory, and it was nginx-conf. So it'll take the place of the default installed one. Alright, and then we can move in the application specific one, so the one we're looking at up here, to the conft directory. So copy config flask2do.conf to etc nginx conf.d, just like that. So there she is. Now a great little tip for updating nginx configs or config files is this command right here. So what this does is it asks nginx to basically check our syntax for configuration files. So I pretty much always do this before I change a config file and restart the nginx server, just to make sure that I haven't done something silly. It catches the vast majority of things. So with that now established, so those configs changed, I can restart nginx and it will reload its configurations. So now I can do a status and we see it's running. And is it enabled? No, it's disabled. So let's enable it. So it reboots, or starts at reboot. Oop, not enabled. Enable. Alright. So that should do it. I should now be able to come here, open up a new tab, copy that IP address once again, go to that new tab, and our Flask app now loads up. And notice that I'm displaying the EC2 instance ID. It's proving that we are in fact running on an AWS EC2 instance. Alright, so that concludes the video. We've now learned how to install Flask, complete with Postgres database, to the AWS Amazon Linux 2 EC2. I hope you found this video useful. If you like working with Flask and you want to learn more about how to deploy more complex and robust and scalable Flask apps to AWS, I have a full-featured course on that topic exactly. So you could go to thecodinginterface.com and click on courses. And here is my course and all the different topics it covers, like the ones that we just discussed, as well as using RDS, which is a managed database service, S3, security roles with IAM, automation using the Amazon CLI, auto-scaling groups and elastic load balancers, giving us the amazing power of horizontal scaling, as well as continuous integration, continuous delivery, which is really the holy grail of automation for us developers, where we can essentially just commit our code and have those code changes automatically flow through an automation pipeline and be deployed to like a staging server, a testing server, or once we get confident enough in our work, straight to a production environment. And to do that, I demonstrate the AWS Code Pipeline Service that works in conjunction with Code Deploy and Code Commit. And I also cover SSL encryption with both Let's Encrypt as well as the AWS Certificate Manager. So lots of really good stuff there. Really good stuff that improves us as developers and makes us more valuable as well. So if you're interested in any of that, please take my course also. And if not, I hope you got some good, useful knowledge out of my video. Thank you.